All right, we're going to use the things we've seen about logarithms and exponential equations to start solving logarithmic equations. Now, some of these aren't going to require you to use the properties I'm going to go over. Um, if there's a more direct route that you see, for just a quick example, if you have something like 5 to the 3x plus 1 equals 25, okay, you know that 5 squared is 25, so that means that this thing must equal 2. So you can just set that equation up, and you don't have to use any of our log properties to do that. So that's one that won't require logarithms. But if they're not nice like that, if this is not a direct power of this base over here, then you have to use logarithms and exponentials in order to solve these. So the log is an operation, just like multiplying, dividing, adding, subtracting, taking the cosine. Okay, these are all operations that we can do. So just like we can multiply or divide both sides of an equation by the same thing, we can take the same log of both sides of an equation to make it simple. So in this case, if I want to get this term, this exponent down from there, because I want to be able to solve for x, so in order to do that, I need to get it out of there. I can't solve for x in the form it's in now. I'm going to take the log of both sides of this equation. The log I want to take is log base 5. So I'm going to take log base 5 of both sides of this equation. Okay, because over on this side now, my log is going to cancel my base out and leave just the 4x minus 3. Okay, and the reason it does that is because if you remember the rules, I've got log with a base of this, and this is a power. This power would come down to the front. And I'd have log base 5 of 5, which is 1. Okay, so this just goes to 1. So then we got 4x minus 3. And that equals log base 5 of 12, which is going to be some kind of a decimal. So let's see what that is. Okay, so if I look at what log base 5 of 12 is on my calculator, remember you have to use a base change formula. You can't just hit log 12 because it's not base 10. So use my base change formula. So I'm going to take log of 12 divided by log of 5, and I get 1.54. Then I can add the 3 over, which would give me 4.54, so plus 3, and then divide by 4, and I get that for x. So say 136. Okay, and I can test that. I type in my original equation back in, and it should spit out 12. So if I take 5 to the power of 4 times my answer minus 3, I get 12. Okay, so that's how you solve an exponential using logs. We can also solve a log function using exponentials. Okay, in order to do that, we're going to exponentiate both sides. We're going to turn both sides of this equation into an exponent of a common base. And that common base is determined by the base of your log. So in this one here, I'm going to make both of these powers on a 3. I want the 3 to match the base there. So when I do that here, these cancel, leave just the x plus 4. And over here I've got 3 squared, which is 9. So that means x is going to be 5. And I can check that. If I put 5 in here, I've got log base 3 of 9. And of course, that would have to be 2, because 9 is 3 squared. Okay, you can combine all this stuff with your expanding and condensing if you need to. So if I exponentiate both sides at this point, I'm going to have 5 to this whole power. Okay, because you can't just take a piece and exponentiate it. You've got to exponentiate the whole left side. So I have log base 5 of 3x plus 2 plus log base 5 of x. This whole thing would be my exponent. And I don't have any rules that allow me to figure out what this is. So what I'm going to do first is I'm going to combine my logs using my condensing rules so that I just have one log. Okay, so I'm adding, which means I'm going to be changing this to multiply. So I've got log base 5 of 3x plus 2 times x. And if I distribute the x here, I've got log base 5 of 3x squared plus 2x, and that equals 1. Now I want to exponentiate both sides. So now this will cancel and leave just 3x squared plus 2x equals 5. This is a quadratic, so I need everything on one side. And now I can either factor or use quadratic formula. Let's see, this one should factor. So I need multiply to be 5. So I'm going to put the 5 here and make it positive. I'm going to put the negative 1 here. Okay, so now I'm getting negative 5 for that. And when I do this, I get negative 3x plus 5x, which is 2x. So that means I can get this thing equals 0, or the other factor equals 0. So over here I'm going to get negative 5/3, and here I'll get 1. We need to check both those answers to make sure they're not extraneous. So I'm going to plug them into my original function. So I'm going to store negative 5/3. I'm going to store that as x. And then I'm just going to type my function as it is. So I need to do base change formula. So I need to do log of 3x plus 2 divided by log of 5 plus base change formula again. So log of x divided by log of 5. And I should get 1. Okay, and that's not working. Okay, so let's see what's happening here. This one's turning into 0. And I'm getting the log of... No, this one's turning into negative 5 plus 2. Let's check it by hand. Log base 5 of... Okay, if I have 3 times negative 5/3 plus 2, 3's will cancel. I'll get negative 5 plus 2, which is negative 3. Log base 5 of negative 3. So log of negative 3 divided by log of 5. Okay, I'm getting an unreal. Okay, so this is an extraneous solution. This doesn't work. All right, let's check 1. So let's store x as 1. And I'll just bring up what I typed in a couple times ago. Okay, so here's my function again. And there I'm getting 1 out. So that means this is the true solution. This is extraneous. Okay, and the reason we're getting no solution when we do this, you can't... It's asking 5 to what power equals negative 3. Well, 5 to a power isn't ever going to turn negative. Okay, it's always going to be some positive. It's either going to be if I have a positive power up here, it's going to get a bigger and bigger positive number. If I have a negative number up here, it's going to turn into a fraction. If I have a fraction up here, it's going to turn into a root. Okay, but none of those are going to turn negative. So this is an extraneous solution. This is the real solution. Okay, and so those are the methods that you'll use to solve exponential and logarithmic equations.